Good day and welcome to my YouTube channel. I'm Arthur Francis Divan. Today we're going to be dealing with Surds, that is mathematics. So I'll try the best I can to have it as simplified as we can. So we say Surds are irrational numbers. Alright? There are the roots of rational numbers whose values cannot be expressed as exact fractions. Example, we have root 2, cannot give us exact fraction. We have root 7, root 12. This product of these roots are not exact values. So all numbers who do not have exact values in their root, it tends to be what? Surds. Alright. Example 4. The root of 4 is 2. So the root of 4 is not surds. It's not part of it because it could give us an exact value which is 2. Then, in a simplified manner, we're going to look at the rules which will govern us or help us to proceed with what we're dealing with today. So let's begin with the rules. The first rule, we say the following are the basic rules mostly used when performing operations on surds. So we have rule 1. The root of PQ can also be expressed as the root of P times the root of Q. So this is our first example, which means that if I have a value which is like 12, for example, root 12 can give me root 4 times root 3, or vice versa. Okay, so this goes together, so you don't forget that, it's important. We have the second rule. That first one is the multiplication rule. The second one is the division rule. If we have 2, the root of P, Q, this can be as root P divided by root Q. So it means that insofar that we can do it this way, we can also do it this way. If it is in this manner, we can bring it back to this manner. So if I have, example, root 70 divided by 3, I can rightly say this is root 70 divided by root 3. They are all the same. So let's take another rule. It's rule number 3, say addition rule. That the root of P plus Q is not equals to the root of P plus the root of Q. So here, a lot of students make the mistake because here we're able, or in this form, we're able to multiply them and we can bring them together. A lot of students will still make the mistake and think that in the division aspect, the same rule applies, but no, they are not equals to. And the fourth rule, which is the subtraction rule, P minus Q is not equals to the root of P minus the root of Q. It is not. Let's take, excuse me, an example to represent what we've done so far. Provided both P and Q are positive, in that sense, these are not equals to each other. So let's take one example. If I have root 20, this can become root 4 times 5. This, and this is the same thing as root 4 times root 5. To that end, this still goes. And thereby, we will be simplifying it as we proceed. But that's just the basic. Now, let's look at something. Basic forms of surds. At what level do we say surd is in its basic form? When I say a surd is said to be in its basic form if it does not have a factor that is a perfect square. So, if the variable given to me, like root 7, does not have a factor in it that is a perfect square, then it is not in its basic, it is in the basic form. But if I have something like root 9, no, root 12, where I know that this can give me root 4 times root 3. This is 2. The root of 4 is 2 times root 3, which is 2 root 3. So realize that this is not in its basic form. It can only be in its basic form if it cannot give you a number that is a perfect square. So this root 7 is in its basic form because it can't give us any variable that is a perfect square. We also have root 2 is also in its basic form, root 3 in its basic form, root 5 in its basic form. All these variables cannot give us what? Any factor that is a perfect square. Okay, so we understand that. Let's move on. Okay, now we look at similar sorts. Sorts are similar if their irrational parts contain the same numeral. Let's take, for example, I have 3 root n and 5 root n. These two sorts are similar. Why? Because the variables inside the root are the same. If I have 19 root 2 and 100 root 2, these two sorts are similar because they have variables inside the root that are the same. But those sorts that are not similar definitely have variables that are not the same. For example, I have n root 3 and let's call it n root 5. These two sorts are not similar. Insofar that there is n here, there is n here, they are not similar because the variables inside the root are not the same. It's like saying, here, I have 3 apples. This is root n. If we decide to call root n an apple, there's another root n. So anywhere I see root n, I call it an apple. So I have 3 root n and 5 root n. I can easily say I have 3 apples and 5 apples because they are the same and I can add them. But if root 3 tends to be apple, root 5 is bananas. I cannot say n apples and n banana are the same. They are not similar because what is inside defines the sort. It defines it all. So these are not similar sorts, but these are similar sorts, and the similarity is defined by the variable inside the root. Only by that we can do our addition or our subtraction. Now, let's talk about conjugate sort. The reason why I'm trying to define the variables or the terminologies used is because we are going to use them when we proceed in our calculations without going back to refer to them, so I have to define them at once. Now, in a simple way, let's say conjugate sort. A sort is said to be conjugate in this manner. If I have root 3 plus root 2, its conjugate becomes root 3 minus root 2. Why is that? Because in the course of our rationalization, it is only in this form that we'll be able to get rid of the root sign, which tends not to be in the denominator or the denominatorial pattern. So in that fact, this is its conjugate. Just know that when you have root a plus, or let me call it minus root b, its conjugate becomes root a plus root b. So I don't need to give us plenty language there. Just know that the conjugate is to change if it is plus, become minus. If it is minus, become plus. That's that. Just take note of that. So let's just simplify sorts and see how far we can go with the understanding or the things we have said so far. So we'll look at simplification of sorts. Let's simplify the first one being root 45. So the first one here is root 45. Now, I will show us, if you remember your lowest common multiple very well, so I'm trying to show us the easiest way in which we can break down a variable to its simplified form so that you can deal with it or any variable given to you without problems. So now, this is root 45. If I want to simplify it, first of all, it's good to do this way. You have your 45 here. Now, 45 divided by 5 will give you 9. This 3 go here will give us 3, and 3 go here will give us 1. So why am I simplifying the surd? The reason is I want to get a variable inside this number which can give me a perfect square. If I can get that, it means I can simplify or break it down further. Otherwise, I'll be stuck because root 45 is not a perfect square. It cannot just give me a direct answer. Like root 9, which is 3, root 5 is not going to give you a perfect answer. So I simplify it by creating a variable inside of this 45 that is a perfect square. So by me doing this, I know that 3 times 3 is 9. And when two numbers can multiply themselves to give you a product, that product is a perfect square. 2 times 2 is 4, the root of 4 is 2. 3 times 3 is 9, the root of 9 is 3. 10 times 10 is 100, the root of 100 is 10. So it means that 3 times 3 here, which is 9, I can now have 9 and 5. Because 9 times 5 will give me 45. So, according to the multiplication rule of surd, it means that if this is correct, therefore I can also have this to be root 9 times 5. We said that in the multiplication rule. So, and if this is also correct, it means that we can also have root 9 times root 5. That is the law. So, now we know that root 9 is a perfect square. That is the essence why I try to get a perfect square in the process of simplifying it. So, root 9 now will become what? 3 times root 5 or 3 root 5. Any of those. So, by so doing, I have simplified the surd to the lowest level. So that is all about simplification. Let us take another variable. Let's say root 98. Number 2. We have root 98. So, like I said, our lowest common multiple knowledge has to be applied also. So let us try to break this down. I have this, and this is my 98. So, the easiest way to begin with is to divide it to get numbers that can give me what? A perfect square. So, I start with 98 divided by 2. I have 49. 2 go here gives me 49. Now, 2 cannot go there again. And perhaps I know that 3 will also not go. But 7 can go. So, 7 go here will give me 7. And 7 again will give me 1. So it means that 49 times 2 is 98. Why do I have to present it in this manner? Because I know that these two numbers can give me what? A perfect square. And this one, although will not. Then, according to the multiplication rule, I can therefore say I have 7 times 7 times 2. Which is 49 times 2. This is also the same thing as root 49 times root 2. And I know root 49 to be what? 7. So this becomes 7 times root 2. Which is the same thing as 7 root 2. So with this, I have simplified it. But my ability to know that the easiest way to go through the simplification is first of all to break the variable or the number into different factors that 2 of them at least are the same, which can give me what? A perfect square. If there are 4 of them that are the same, they can still give me what? A perfect square. Okay, let's take another one to simplify. Let's take root 240. So root 240, I can still do the same thing. I come back here, put my 240. I use 2 first. So I want to break it down. 240 divided by 2 gives me 120. We'll continue small. Divide by 2 will give me 60. 2 go here now will give us 60. 2 go there again will give us 30. 2 go here again will give us 15. So 2 cannot go again. 3 go here will give us 5. And 5 go here will give us 1. But I know that these numbers, 2 times 2 will give me a perfect square, times 2 again will give me a perfect square. So which means 4 times 4 will give me a perfect square, which is 16. 16 times 15. So now I can easily come here and say 16 times 15. Now 16 times 15 is 240. So you know that you're correct. So if this is a perfect square, this is a perfect square indeed, and according to the multiplication law of Surds, it means that I can still break this down into root 16 times root 15. And I know root 16 being a perfect square will give me 4 times root 15. And this means it's 4 root 15. So with this, we can simplify any variable, provided we have the understanding or the common sense that we can break down the variable, no matter how big it is, into something we can make use of. Let's simplify one last one, and so we'll move on. Let's take root 50. Root 50. I'll come back here again. I say 50 is here. 2 go there will give me 25. 5 goes there will give me 5. 5 go here will give me 1. So this is the same thing as 25 times 2, which we know that is 50. So I'll come back here and say 25 times 2 is the same thing as root 50. That's the multiplication rule. So if this is true, and I move on to say this is the same thing as root 25 times root 2. And the root of 25 being a perfect square is 5 times root 2. And this is 5 root 2. So by simplification, we move on gradually. So with our knowledge of breaking it down to the lowest common multiple, we'll be able to get all the factors of that variable. And we'll be able to also know those factors that are what? Perfect squares. And as such, we can thereby proceed to simplify our solved. Now, let's say the next one we're done with simplification. Express the following as a single Surd. To express a Surd as a variable as a single Surd, let me break it down. Let's take one so that I can explain. We have 2 root 5. 2 root 5. They say we should express this as a single Surd. It means that we should turn this variable all into one root. There should be inside one root, like root 10 or root 20 or root 30. But it should all be inside one root. Inside one sign or symbol or inside one root. For us to do this, in mathematics, remember, whatever you are doing to a particular number, ensure that the variable does not change its position or its value. It doesn't diminish or increases. It maintains its status quo. So let's see, how do we do that? I want to put this inside the same Surd, but the same variable too should be maintained. It shouldn't be changed. So the only way I can do that, for example now, instead of me to put root 2, if I put root 2, it is not the same thing as 2. It's different. So what can I do to maintain this 2 itself? I will do it this way. I'll square it. Now, why should you square it? First of all, remember, the root sign. Let's discuss, okay? The root sign is the same thing as 1 over 2. Alright, and I want to maintain 2. They gave me 2 that I should put it inside the root. So this is root 2. I want it to be inside a root that maintains its value as 2. So for me to make this 2 be inside the root and maintain its value as 2 is this. I'll come here. I have my 2, which is given to me. And I know that when I square it is 4 and root it becomes the same thing. How? Because this root is the same thing as 1 over 2. It means that 2 raised to the power 2 raised to the power 1 over 2. This is what this variable now means. But how is this variable 2? Is this. According to the Powers law of indices, it says that when a number is raised to a given power, which is again raised to another power, that this number 2 is said to be in powers, that the powers are multiplied together for final result. It means that 2 raised to the power 2 times 1 divided by 2. 2 times 1 is 2 divided by 2 is 1. So 2 raised to the power 1 is 2. So for me to square and root the variable, maintain that that variable is still 2. Because I can prove here using laws of indices that that chemistry or that reaction still maintains the value 2. So, in a simple way, if I say put 3 in sort form and make sure it maintains its value, you should know that you are going to square it and root it. If I give you 9, put it in the sort form and it maintains its value, you put 2, square it by 2 and put your root. That is how the chemistry goes. You should always remember these indices will help you through. So now, having said that, I can easily come down here and say this variable is the same thing as the root of 2 squared. This times the root of 5. That is what it means. This means 2 times root 5. 2 root 5 means 2 times root 5. So this is the times here. So here is root 2 squared is 4 times root 5. And I know that multiplication law says I can make it as root 4 times 5. The same thing as this. And this is the same thing as root 20. So by so doing, this variable, they said I should put it in a sort form. I've been able to do that, and the answer is root 20. 17 root 2. Root 2. Since I've discussed that earlier on, that the easiest way to go is just to root it and square it times the root of 2. So now you ask, what is 17 squared? That is 289. So here become root 289 times root 2. Now, it's the same thing as multiplying 289 times 2. That gives me root 578. So by so doing, I've been able to put it in the same form. In the same sort form. They say express the following as single sort. They are now what? A single sort. Maybe we should take one, maybe 2 other examples. I have 5 root 3, which is the same thing as root of 5 squared times root 3. And this is the root of 25 times root 3. And this is the root of 25 times 3, which is the root of 75. Another one. 4 root 3. 4 root 3, this is the same thing as the root of 4 squared times root 3. The root of 16 times root 3. The root of 16 times 3. Don't forget that. Okay, now 16 times 3 is 48. So this becomes the root of 48. You don't forget what we said. You root it and square it. Multiply by the root 3. The square of 4 is 16. All are still in the same root times root 3. Now, 16 times 3, which is this, I can now put it in this form. Multiplication law of sort permits that. And when I do that, I have root of 48, which is still allowed. Let's take one more example on that. 7 root 6. So we have 7 root 6. This becomes the root of 7 squared times root 6. What is 7 squared, which is 49 times root 6? And this is the same thing as 49 times 6. And that is 49 times 6, 294. This is the root of 294. So now we can express any sort as a single, any variable as a single word sort. So let's look at addition and subtraction of sort. In addition and subtraction of sort, remember very well we talked about similar sort and sort that are not similar. It is that principle which we are going to use to deal with what addition and subtraction of salt. Okay, only salt in the same basic form can be either be added or subtracted. Sometimes there may be need to simplify such salt before doing either the addition or the subtraction. So they have to be in their basic form. Why? If I have root 20, let's say plus root 30, I can't just add them. You have to sometimes simplify it to be in the form whereby they cannot be simplified further. And that is when you know whether you have to add them or subtract. Because by so doing, you'll be able to see salt that are similar that you add, or those that are not similar, and so on. So in this manner, you can't tell whether there are similar salts here or there are not. So let's take our first example. Evaluate root 32 plus 3 root 8. Root 32 plus 3 root 8. Let me confirm that. Root 32, okay, where are we? 32 plus 3 root 8. So like they said, we have to simplify when needed. So we can see what to do. So 32 first, I want to simplify it. This is my 32. 2 go here will give me 16. 2 go here will give me 8. 2 go here will give me 4. 2 go here will give me 2. 2 go here will give me 1. Same. So 4 times 4 is 16 times 2 will give me this 1. So I can easily come here and say 16 times 2 for 32. Plus, this is 3 root 8 is 4 times 2 will give me 8. The same thing here. So I have 8. 2 will go here will give me 4. 2 will go here will give me 2. 2 will go here will give me 1. So this 2 is a perfect square. That's 4 and 2. So now I proceed. This is the same thing as root 16 times root 2. Plus, this is 3 times root 4 times root 2. Now, this is a perfect square. Root 16 is 4 times root 2. Plus, this is 3 times root 4 is 2 times root 2. Now, this gives me 4 root 2 plus 3 times 2, 6 root 2. Remember, we say we can only add salt that are similar. If you check it, we have 2 root 2. We have here root 2. They are similar. So they say 4 root 2 plus 6 root 2 will give us 10 root 2. So this is like 4 apples plus 6 apples will give us 10 apples, which is now 10 root 2. So that's how that goes in the addition of salt. Let's take another example in terms of addition. Okay. Evaluate 7 root 3 minus 7 root 3 minus root of 75. Root of 75. Okay, that's correct. So this one is already in its basic form. We can't break it further. So, but this one is not. We have to simplify this to take it to the basic form. So I will draw my table as usual. 75. So 75 divided by 5. 5 goes here. Will give me 35. Oh, 15. Sorry. Will give me 15. 5 go here will give me 3. 3 go here will give me 1. So this is 25 times 3 will give me that. So now, I now have 7 root 3 minus the root of 25 times 3. 25 times 3 is 75. I'm trying to simplify that. So I have 7 root 3 minus the root of 25 times the root of 3. 7 root 3 minus root 25 is 5 times root 3. So 7 root 3 minus 5 root 3. Now, Root 3, root 3, they are similar. It's like 7 apples minus 5 apples will give us 2 apples. So 7 root 3 minus 5 root 3 will give us 2 root 3. Okay. Let's take another one. Evaluate 3 root 48. 3 root 48 minus root 75 minus root 75 plus 2 root 12 plus 2 root 12. So 48 and 75. So let's break this down. So first of all, start here. Our 48 as usual, don't forget that. This is 24. 2 go here will give us 12. 2 go here will give us 6. 2 go here will give us 3. 3 go here will give us 1. So this is 4. 16 times 3. So when you confirm that 16 times 3 will give you 48. So we come here and say 3 times 16 times 3 minus 75, which is 25 times 5 times 3. I've done this just in the previous example, so this is 25 times 3 plus 2 root 12 is 4 times 3 will give us 12. So I want to break that down. I have 3 times root 16 times root 3 minus root 25 times root 3 plus 2 root 4 times root 3. So when I come down, I have 3 times root 16 is 4 times root 3 minus 25 is 5 times root 3 plus 2 times root 4 is 2 times root 3. 3 times 4 is 12. 12 root 3 minus, this is 5 root 3 plus 4 root 3. Now, 12 apples minus 5 apples plus 4 apples is what? 12 plus 4 is 16. 16 minus 5 will give us 11. So all of them are 3, 3, 3. So that gives us 11 root 3. So you can confirm that 12 minus 5, which is 7, plus 4, which is 11. So that's what we have. So by simplifying it further, that is where it will take us. So don't forget, addition and subtraction of sum have to deal with variables that are similar and they must be in their basic form. So whatever is given to you, you have to simplify it to its basic form first before you add or you subtract. And for you to add or subtract, that means that the variables are either similar. That is where you can add them. Otherwise, you cannot. Okay, quickly, let's look at multiplication of surds. So we say that if the first 2 rules on surds explained earlier, which I just did earlier, should be carefully studied again before carrying out multiplication. Remember, in terms of multiplying, you are technically simplifying alongside, and the same thing goes with the division. So let us take simplify root 45 times root 28. Simplify root 45 times root 28. Let me be sure. 45 times root 28. Okay, in 45, we simplify. What do we do then? We have our 45 here. I think that is 9. 45 divided by 5 is 9. So this gives us 9. And let's call it 3 go here, give us 3. 3 go here, 1. So this is 9 times 5 for that. So now I have my roots 9 times 5 will give me this. Times 28. 28. 2 goes there will give me 14. 2 goes here will give me 7. 7 goes here will give me 1. So this is 4 and 7. So 4 times 7 will give me 28. Now, if that is true, let's break it down. I have this as root 9 times root 5 times root 4 times root 7. That is the multiplication law permits that. I have to break them out. So root 9 itself is 3 times root 5 times root 4 is 2 times root 7. These two numbers cannot be simplified further. So 3 times 2 first is 6 times root 5 times 7. So this is 6 root 5 times 7 is 35. And I know I cannot break 35 further to give me a simpler variable. So that becomes my answer. So let's take another example. Root 60 times root 180 divided by root 75. Root 75. Now, I can take it, instead of simplifying it, I can just multiply through and get to a common base and proceed. 60 times 180, let me make it in a bigger form. 60 times 180. Okay, here I have root 10,800 over root 75. Now, division law still permits me to say root 10,800 divided by 75 will give me 144, root 144. And root 144 is 12. It's a perfect square. So we have root 144. That gives me 12. So I can easily take that. I multiply these two. Multiplication law permits that. Divide by root 75. Division law takes that. So this is what I have. And I can put it in this same form. When I divide it, I have root 144. And root 144 divide, the root of 144 is 12. That is a perfect square. Okay. Let's go down to root rationalization. So, we talk about sort rationalization. Rationalization of sort is concerned with the process of removing irrational number from the denominator. So, when the variable at the denominator is irrational, we remove it. And that is how it goes. So let's start with the easiest one we can begin with. 2 over 5 root 3. Number 1. 2 over 5 root 3. In sort, once you have a root sign at the denominator, which is irrational, you must remove this variable. So to rationalize this means you have to multiply this root sign both up and down. So I have times root 3 over root 3. 2 times root 3 is 2 root 3 over 5 root 3 times 3 is, root 3 times root 3 is 3. Alright? The root of 3 times another root of 3 gives us 3. So we now have 5 times 3. So this is 2 root 3 over 15. That is our answer. We cannot cancel anything further. Don't forget that the root of two numbers which are the same, when you multiply them together, you get this, it becomes a normal number. So let's take another example. Evaluate 3 over root 3 plus root 2. Root 3 plus root 2. Okay, now, in this, we are going to rationalize by multiplying this up and down. But at the same time, we have to look for the conjugate of this. The conjugate of this is minus. So this becomes, this times root 3 minus root 2, both up and down. root 3 minus root 2. So 3 times root 3 is 3 root 3. 3 times minus root 2 is minus 3 root 2 over root 3 times root 3 is 3. Root 3 times minus root 2 is minus root 6. Because 3 times 2 in multiplication is minus root 6. Plus root 2 times root 3 is plus root 6. And plus root 2 times minus root 2 is minus 2. Now we move on. This is the same as 3 root 3 minus 3 root 2 over this minus root 6 plus root 6. They are the same, so they will cancel. So I now have 3 minus 2. So in that sense, I have 3 root 3 minus 3 root 2 over 3 minus 2 is 1. I have two variables which are common. This is the same thing as 3 root 3 minus 3 root 2. Now, there is 3 here, there is 3 here. I can easily see 3 open brackets root 3 minus root 2. This and this are all the same. Okay, let's take another example in rationalization. They say we should simplify simplify 1 over 1 minus, where is it? 1 minus root 3 all squared. Normally, if not for the square sign, we are just supposed to rationalize this by changing the conjugate and we proceed. Let's be certain, 1 minus root 3 all squared. So for us to be able to solve this, it means that 1 minus root 3 are in two places. So let me simplify that first before we move further. Alright? So by simplifying that, I have 1 minus root 3, 1 minus root 3. I want to expatiate, to simplify this. So 1 times 1 is 1. 1 times minus root 3 is minus root 3. Minus root 3 times 1 is minus root 3. Minus root 3, minus root 3 times 1 is minus root 3. Minus root 3 times minus root 3 is plus 3. Alright. In this sense, 1 plus 3 here is 4. Minus root 3 minus root 3 is minus 2 root 3. Minus root 3 is 1. Minus root 3 again, like minus 1 minus 1 is minus 2. So I have minus root 3 minus root 3 is minus 2 root 3. So now I have to proceed. 1 over, I'm bringing it back, 4 minus 2 root 3. I have to simplify by getting with their conjugate. So this is times 4 minus 2 root 3 over, this is plus 4 plus 2 root 3. 1 times 4 is 4. Plus 1 times 2 root 3 is the same. Over 4 times 4 is 16. 4 times 2 root 3 is plus 8 root 3. Minus 2 root 3 times 4 is minus 8 root 3. Minus 2 root 3 times, minus 2 root 3 times plus 2 root 3 is minus times plus is minus. 2 times 2 is 4 times 3. Root 3 times root 3 is 3. So I come back here, I have 4 plus 2 root 3. Now this and this are the same. I cancel these two. This is 16 minus 12. 16 minus 12 is 4. This minus 12, yes, is 4. So I can easily come here. I have 4 plus 2 root 3 over 4. This is the same thing as saying 4 over 4 plus 2 root 3 over 4. And this is 1 plus 1, 2. So this becomes root 3 over 2. So in this sense, this is what it is. This is our final answer. Now, let's proceed. Let's take another variable. Evaluate 2 plus root 3. 2 plus root 3 over, where is it? 2 plus root 3 over root 2 minus root 3 over root 2 minus root 3. So the conjugate here is times root 2 plus root 3 over root 2 plus root 3. Now we expatiate. 2 times root 2 is 2 root 2. 2 times root 3 is plus 2 root 3. Root 3 times root 2 is plus root 6. 3 times 3 becomes plus 3. Root 3 times root 3 is 3. Don't forget that. We'll come back here. Root 2 times root 2 is 2. Root 2 times plus root 3 becomes plus root 6. Minus root 3 times root 6 becomes minus root 6. Minus root 3 times plus root 3 is minus 3. Okay. Let us move. Now I have 2 root 2 plus 2 root 3 plus 6 plus root 6 plus 3 all over. These 2 will cancel out to become 0. 2 minus 3 is minus 1. So I can easily say I have minus 1, 2 root 2 plus 2 root 3 plus root 6 plus 3 as my answer. Or better still, we leave it like this. Anyone we choose to deal with. Now, let us take another example and move on with it. Express 14 minus 8 root 60. 14 minus 8 root 60 over 6 root 20. 6 root 20 minus 10 root 2 minus 10 root 2. 0 root 2 root 12, sorry. In the form a root 5 plus b root 3 plus b root 3. So they are telling us that the form in which we have to leave our answer must be in this manner. So a root 5 means that at the end we are going to have answer where our answer is going to be in the form where there will be a root 5 and there will be a root 3. Whatever is attached to that root 5 becomes our A. Whatever is attached to that root 3 becomes our B. That is what they are saying. So let us go on and simplify. Okay, here we begin. 14 minus 8 root 60. I'll come back here. 62 here will give us 30. 2 here will give us 15. And what again? 5 here will give us 3. Yeah, and 3 here will give us 1. So it's 4 times 15. So here is 4 times 15 over 6 root 20 is 4 times 5 will give us 20 minus 10 root 12 is 4 times 3 will give us 12. So let's continue with our simplification first. and see what we get. Here is 14 minus 8 times root 4 times root 15. Remember that, we have explained that earlier. Over, here is 6 times root 4 times root 5 minus 10 times root 4 times root 3. So, here we are almost having something very close here. Let's go on. We have here as 14 minus 8 times root 4 is 2 times root 15 over 6 times root 4 is 2 times root 5 minus 10 times root 4 is 2 times root 3. Let's come back. So now we have 14 minus 16 root 15 over 12. 6 times 2 is 12 root 5 minus 10 times 2 is 20 root 3. Okay, this is where we are. We have to rationalize. Rationalize, remember our conjugates. We have to continue with that. So now, rationalizing, I have 12 root 5 plus 20 root 3 over 12 root 5 plus 20 root 3. Now, 14 times 12, I want to multiply. 14 times 12 will give me 168. I have 168 root 5. 14 times 20. I have 14 times 20 here will give me plus 280 root 3. Now, minus comes in. 16 root 15 times 12 root 5. 16 times 12 first. 16 times 12 first. We have 192. 192 root 15 times 5. 15 times 5 will give me 75. Done the first one. Minus plus will give me minus. 16 times 20 is 16 times 20 is 320. Root 15 times 3, 45. All over 12 root 5 times 12 root 5. 144 times 5. Okay, so this is 12 times 12 is 144. 144. Root 5 times root 5 is 5. 2 times 5. 12 root 5 times 20 root 3. So 12 times 20 first, 12 times 20 first, give us 240. So that's plus 240 root 5 times 3 is 15. The other way. Minus root 20 times 12. Root 20 times 12 is still 240. So this goes minus 240 root 3 times 5, which is 15. And finally, minus times plus here is minus 20 times 20. 20 root 3 times 20 root 3 is 400 times 3. Because 20 times 20 gives us 400. Root 3 times root 3 is 3. So now let's proceed. Now, we have 240 root 15 minus 240 root 15. This will cancel out. This will cancel out to 0. Now let's go back up. I have 168 root 5. I can simplify this further. So 75, let's break it down first. 75 here. 75 divided by 5 is 15. 5 goes here is 15. 5 goes here is 3. 3 goes here. So this one. So that's 25 times 3 for 75. So let me just keep it here. 25 times 3. So I'll take this out. Let's go on. Now I have 168 root 5 plus 280 root 3 minus 192 root 25 times 3 minus 320 root that of 45. We have 45 divided by 5. It's 9. It's 9. 9 to 1. So here we have 9 times 5. All over. Here, 144 times 5. 144 times 5 gives me 720. This 2 is 0. Minus 400 times 3. 400 times 3 gives me 1,200. Now, let's proceed. I have to, okay, one more step before I clean. Okay, now here I have 168 root 5 plus 280 root 3 minus 192 times root 25 is 5 times root 3 minus 320 times root 9 is 3 times root 5. All over 720 minus 1,200. That gives me minus 480. Minus 480. Let's clean this other side. Alright. Now, this is root 5, this is root 3, this is 5 times this, to compress them. Okay, let's proceed. 168 root 5. 168 root 5. Let's check another root 5 here, which is 320 times 3. 320 times 3 is 960. Okay, minus 960 root 5. Minus 960 root 5. I'm trying to compress it because of this side is shorter. Now this is plus 280 root 3. Plus 280 root 3. 192 times 5. 192 times 5 is 960. So minus 960 root 3. Minus 960 root 3. All over minus 480. Okay, now let's see what we're doing. Let's say 5 and 3 comes. Okay, 168 minus this will give us a minus, and this will also give us a minus. So let's proceed. 168 minus 960. 168 minus 960 is equal to minus 792. This is minus 792 root 5 minus, because I know it's still going to give us minus 280 minus 960. 280 minus 960 is minus 680. Minus 680 root 3. All over minus 480. This means that this divided by this over this divided by this. So I have my minus 792 root 5 over minus 480 minus 680 root 3 over minus 480. That's what it means. This will cancel this. Now, 792 divided by 480. 792 divided by 480. It's 1.65. So I can have it 1.65 root 5 plus this divided by this. 680 divided by 480. 680 divided by 480 is 1.4. Let's just take it 1.42. 1.42 root 3. Now, they are asking us that we should leave our answer in the form of a root 5. Let's come back here. A root 5 plus b root 3. So, this is root 5, this is root 3. It means that our A is 1.65 and our B is 1.42 because 1.42 is the variable attached to root 3 as described by then, and 1.65 is the variable attached to 5. So this 1.65 becomes our A and 1.42 becomes our B. Now, it may be very long, but if you follow the principles gradually, you will certainly get to the bottom of it. So let us solve just a few more exercises and see what we can get out. So let me take this out. 4 root 8 plus 3. 4 root 8 plus 3. 4 over root 8 plus 3. So here, I would like us to deal with this first. Whatever we have, then we add this. Okay, let me start with this. This 4 root 8, I rationalize it by multiplying it by root 8 over root 8. So this is 4 root 8, 4 times root 8 is 4 root 8, over root 8 times root 8 is 8. So by this, I've rationalized it plus 3 over 1. That's what it means. So we now apply fraction. Now, the LCM here is 8. 8 divided by 8 is 1 time. 1 times this is 4 root 8. Plus 1 going to 8, 8 times. 8 times 3 is 24. If I'm not mistaken. 4, 5, yes. 3, 5, 15, 3, 6, 18, 3, 7, 21, 3, 8, 24. Okay, that's 24. So our answer now becomes, I either leave it like this, or I say it is 4 root 8 over 8 plus 24 over 8. Now this is 2. I'm going to step 1. Goes there 2. So this becomes root 8 over 2 plus 24 divided by 8. 24 divided by 8 is 3. So this becomes 3. So the question 4 over root 8 plus 3 is root 8 over 2 plus 3. That is our answer. So let's quickly take another example. Okay, 10 root 2. Let's just take a simpler one. 10 over root 2. This will become irrationalized by root 2 over root 2. So this becomes 10 times root 2 is 10 root 2 over 2. Root 2 times root 2 is 2. 1 times 5. So this becomes 5 root 2. That's our answer. Let's just take more and more. 13 over 9 root 5. 13 over 9 root 5. So we multiply rationalize by root 5 over root 5. So this is 13 root 5 over 9 times root 5 times root 5 is 5. So this is 13 root 5, 9 times 5 is 45. I think we should take one more. Root 2 plus root 5 over 10. Root 2 plus root 5 over root 10. Root 2 plus root 5 over root 10. So this, by rationalization, becomes root 10 times over root 10. Yeah. So root 2 times, multiply root 2 times root 10 is root 20. Plus root 5 times root 10 is root 50. Over root 10 times root 10 is 10. So root 20 is the same thing as root 4 times 5 plus root 50 is the same thing as root 25 times 2 over 10. And this is the same thing as 4. The root of 4 is 2. 2 root 5 plus 25. The root of 25 is 5. 5 root 2 over 10. So if I have 2 root 5 plus 5 root 2 over 10, that can become 2 root 5 over 10 plus 5 root 2 over 10. 1, 5. So I have root 5 over 5 plus 2. Root 2 over 2. So this becomes the answer. So in rationalizing, it is important that we remember our conjugate. How do we deal with them? Similar sort. What sorts are said to be similar? Basic forms of sort. What level do we say the form is in its basic form? And also to know that when we talk about leave your answer in the form of A and B, whatever is the value attached to A becomes, attached to root whatever it is as A root something, that becomes your A, or B root whatever, that becomes your B in the course of your solving solutions. So with that, I think we can come to a rational conclusion. Thank you.